Hey, welcome back. This is the 10th and final episode of my series on how to design a Telecaster in Fusion 360. In this episode, we will look at setting up the toolpaths to cut the body. As always, if you like this, please give it a thumbs up. If you want to see more videos about guitar design and guitar CNC, please hit the subscribe button. And without further ado, let's get on with it. So we're going to start in the manufacturing workspace, and I have the two-piece body displayed here. I did want to say that the final files for the Telecaster and the file that includes the cam as well will be on my Patreon site, and there's details to that listed below this video. So today in this episode we're going to go over cutting index holes in the stock, which is what this body index setup is all about. Then we're going to actually cut the bottom of the bass. So that's going to include the roundover, it's going to include these ferrule holes, and also the 4 holes to mount the neck onto the body. The next setup, we flip the part over, and we still don't have the cap attached yet, but now we can cut basically these electronics wire chases. And I did cut the 3 cavities here as well. Those actually get cut twice. Really the only reason for that is I was struggling cutting these 2 wire chases only. So we're going to go ahead and cut the pickup cavities and the control cavity in this piece. And then in our last setup, we'll glue the top on and cut down the remainder, the top part of the cap for these cavities. And we'll also all at once cut this neck pocket out. And then there'll be a final cut around the perimeter of the body. So let's get started with the index. So if I activate that setup, you can see that I've got a piece of stock here. And the reason that I modeled a piece of stock is because I want to put these index holes in here and I want to control where they go. So let me go back to the design workspace and I'll show you what I did. I've got a cam component, and within that I've got a couple nested components. So I've got a neck stock, which we saw in the previous video, and this one, this body base stock. So this is the stock just for that bottom part of the body. And I kind of struggled as far as, I wanted to simulate what Fusion does in its manufacturing workspace on how to get a rectangle to start at basically the bounds of the outer portion of the body. So let me hide the bodies and I'll show you what I did in this bounding box sketch. So I'll go ahead and open that up and let's look at it straight on. So I kind of struggled with making a bounding box exactly centered over the perimeter of the guitar. So I want to show you what I discovered, which I think is a pretty easy way of doing it. So let me go ahead and delete most of this sketch. So I'm going to leave in here this projection which came from the outer perimeter of the guitar body, which was used to extrude the guitar body. So starting there, what I did was I created a rectangle, and I went ahead and made this construction geometry. So I'm going to double click on it and press X. Now the trick is to make the 4 sides coincident with the outer part of this guitar outline. So I'm going to click on one side at a time and go to my coincident constraint. And then the hardest part is actually getting these curves to select for some reason. I don't know why it's so hard, but if you just hover over it at the right spot, there, I had it right there. Boom. Okay, same here. I'm going to click on the line, hover until I get the curve selected. And same thing here. I'm still in my coincident constraint, so I click on the line, I click on this curve, and same thing on the final one. Now here I've got a couple of curves to select, and I can see from the grid that this curve exceeds the horn right here. So I'm going to click on this one. Is it doing it? Okay, there it is. So that's a rectangle that's absolutely as tight to the body perimeter as you can get. And I think this simulates what happens in CAM, in the manufacturer workspace, when you center stock over your bodies. So from there, it's pretty straightforward. I mean, I'm going to make another rectangle. This one's not going to be construction geometry. This one's going to be the outline of the stock. So basically, I want this centered over the center of this inner construction geometry rectangle. So I'm going to go to my line tool and just go up and down this line until I get to the center. Click here, go straight across. And again, I'm going to hit my X key on that to make that construction. And then a vertical line, again going from the horizontal centers of these lines. And I will click on that and hit X there to make that construction. Oops. I'm having trouble selecting that. You know what? I'm going to undo that. And it looks like we've got a line there already. Ooh, I undid one. A little too far. Okay. So I think we have a vertical line there to center from. All right. So now I know that the stock was 15 by 19 when I defined it in the manufacturing workspace. So I'm going to do dimension from here to my center line and make that 15 divided by 2, 7.5. And then I'll hit D, come over to the center here. And this time I won't even type in that formula. I'll just come over and click on this dimension. So the two will change if we needed to change them. So 7.5 and 7.5 is our 15. Do the same on these top and bottom ones. So with my dimension tool, I don't actually want to go there. Let me undo that. I want to go from this point to the center. Okay. And this is going to be 19. So half of 19 will be 9.5. And then I'll do the same thing on the bottom line of the outer rectangle and click on this 9.5 dimension. Okay, so now when I just click on this line, I can see in the bottom right corner of the screen that's 15. When I click on this, that's 19. And it's perfectly centered. So finish sketch, and then it was just a matter of making another sketch for index holes. That's this sketch right here, which has got 2 index holes. I believe I came in 3/4 of an inch from the edge of the stock. All right, and we do have an extrusion error here. Let me go ahead and re-extrude that. I'm going to delete this and do another extrude. So I did one extrude already, which was in the timeline, which is our stock. And now it looks like, you know, I don't think we need to do that. I think when that stock got extruded, let's do an edit feature. Everything was selected except for the holes. So you can see three profiles were selected. Let me kill that and show you again. So this profile here, that was not selected. Okay, so this profile here, this one in the middle, and that one there. And okay. So if I do it that way, now I need to punch these holes out. So sorry, one more extrude, and we're going to extrude this hole and this hole. These are our 2 index holes that we'll put 3/8 inch dowels in. And I'm going to pull that down and then just type in a distance of all to punch those through the stock. Okay, so now when we look at this, we do have an index hole through. From the very top, we should have an index hole through here too. Okay, so I can turn off the sketches. And now in the manufacturing workspace, For this body index setup, what I did was I actually picked from solid in stock, and I selected the body from the model. I went into the CAM workspace, and this is the body that we just created, so that's what's selected. And then it's just a matter of doing the right work coordinate system. So here I'm going to pick from a box point, and I'm always going to pick the middle. Let me get my Z going up. So I just flipped on this arrow to get Z up. On my machine, X is the long dimension on the CNC spoil board, and Y is going to the left. So that's a work coordinate system that works for me, but I want to specifically be in the center of the stock because we're going to be flipping about the X-axis here. Okay, so that's all we need to do in the body index. And you can see the piece kind of spun around. What I like to do is have the same view that I'm looking at from where I'm working on the CNC machine. And easy way to do that is to go up to these named views. I've already got one called CNC Top. And so if I click on that, you can see that's the view, which is fine. So now I'm going to assign that view to the workspace that we were just, to the setup we were just working on. So if I go and right click on body index and go down to associate named view, I can pick the CNC Top. And then when you activate a setup, it's going to show that. So for instance, if we were for some reason flipped upside down, I click on this activate button, it spins around and shows us the proper perspective. Okay, so let's look and see what we need to do inside here. So I need to regenerate this because I just changed my stock. That's what this error is about. If I double click on that error, it's saying some certain things are invalid, but let's see. Let's just do a Control G to regenerate those index holes. And did that work? I think we might need to reselect them. So I'm going to double click and I'll say no here. So I'm using a 1/4 inch end mill. Okay. And you know what? It looks like we're upside down with our tool. Let me activate here. Okay. And double click here. And I'm not sure why we're upside down. Let's go ahead and clear all our stuff. And we've got a 1/4 inch bit selected. And we'll go to the hole, select that in our geometry. And I've also got checked here, select same diameter. So when I selected one hole, it selected both of them. And now Fusion fixed its problem of having the tool on the wrong side. So this is the only toolpath we're going to have in this setup, and it's specifically just to cut these index holes. So if I go ahead and simulate this, you can see the bit going down in the two holes and cutting our 3/8 inch dowel holes. Now, one of the things I want to check for here is when we put this piece of stock on the machine, I'm going to have a fixture board, a piece of MDF that I can cut into just below it. So I want the bit to actually go down, not just through this stock, but also into my MDF fixture. So if I double click and go to heights, you can see what I did here. I set the top height, where it starts cutting from, as the whole top, the bottom height, where it cuts to, as the whole bottom, and an additional 1/4 inch, so an additional downward 1/4 inch on the Z-axis. So now when we simulate this looking from the side, we should be able to see, if I slow it down enough, should be able to see that bit coming through and cutting into what will be MDF down there. Now the thing you have to remember is if you're making multiple bodies using that fixture again, you probably want to go into the heights of this particular toolpath and change this back to 0. You don't want to have to recut that hole. Okay, so that's our first setup. So the next setup I call body bass bottom. So, this is a two-piece bass. Let's go back to the design. And if I turn on our bodies here and our top, and if I hide the stock, which is down here, so I'm going to hide all of the cam stuff, and go up to the very top here to show this a little bit better. Okay, so here's our two-piece, and what we're cutting right now is the bottom side of the bass. Okay, so back in our manufacturing workspace, if I click on this setup, we'll see, the model that I've selected, which is the base of this guitar body, and the stock. So when you're here in your body index setup, you probably want to have the A side of your piece, which is going to be the outside, the bottom of the guitar, up, because then you don't have to reposition it when you go into this setup. You'll just be cutting the bottom side. So what we're going to do in this setup is we're not going to surface the top, because what I do is I just cut this very accurately on my planer and get a nice smooth surface on both sides. So this is an 1.25 inch thick piece that's been previously glued up. And that way all we have to do is cut the ferrule holes and cut the neck mounting holes and do a round over on the edges. And before the round over, we're actually going to cut a little bit of the contour to give us enough space to do the round over. So let's open up this setup and see, take a look at things. First, let's go into the setup itself. So I double clicked on body bass bottom, and you can see for the stock, we're getting the stock from the preceding setup, which was the stock that was selected in the cam section of our model. And coordinate work system stays the same. It's on the top of this piece. So basically, and all I had to do was go into the model itself. I'll open that up. Let me close these named views, and I'll open up the model. All I had to do was go to the body section here and select this bottom right here. And that's what it shows up here. So that's what we're going to be modeling. So I'm going to cancel out of here and collapse our model. All right. So with body bass bottom setup open, we can see we've got 4 toolpaths here. And let's go ahead and simulate the whole thing. So I'm going to click on the setup, click on simulate, and now we see that we've got green. I'm in this comparison mode here in the simulate dialog box. So once again, green represents parts of the model that are already to their finished position. Blue is you need to cut more. Blue is showing stock that hasn't been cut down to the model. So you can see these ferrule holes have not been cut yet. Okay, so let's go ahead and do a simulation. There are the ferrule holes being cut. Speed things up a little bit. There's the 4 mounting holes. And now this is a perimeter cut that doesn't go down very far. It probably goes down 1/4 inch if I remember. But you can see it's doing 2 passes around the outside. What that's doing is opening up enough space for our ball nose bit to do the round over without colliding with anything. So we get a much cleaner look on our round over. And now we're in the round over, which takes a while, so I'm going to speed that up a little bit. A lot of little passes to do that round over. Okay, and now round over is done, so our setup is done at this point. So I'm going to close it up, and then let's look at the details of each one of these tool paths. So the ferrule holes is a bore operation, so we're cutting a hole with a bit that's smaller than the hole itself. So I'm going to use an 1/8 of an inch bit. Geometry, basically all you have to do is select a single hole here if this checkbox is checked. So any same diameter holes are going to be selected automatically. So all I'm doing is clicking inside this hole, and that's it. The heights, I'm starting from the whole top and I'm going to the whole bottom. And I think that's what defaults when you select a bore operation. And that's all you pretty much have to do. And you can see the toolpaths here. So it's spiraling down into that hole and going down to the base of the ferrule hole. All right, so that's the first toolpath. The next is another boring operation, selecting these 4 holes. So I'm going to open up the neck mount holes toolpath. We're using the same bit, so we don't have to do a tool change here. Geometry, did the same trick. Select same diameter is checked, so all we have to do is select one of these 4 holes. The other ones get selected automatically. Same with the heights. Now this is interesting. These holes are going to go all the way through. But we have a neck pocket that's cut out. When I set this up, I wasn't thinking about the neck pocket, and I wanted to go a little bit beyond the bottom of this guitar body to make sure I went all the way through. But now that I'm thinking of it, I actually don't need to do that. Don't even need to go to 0 here. 0 would be fine. We could say instead, we can go to selection and say, okay, we're going to select this face right here, which is really as far as it needs to go. But I want to go a little bit farther than that. So let me do minus 0.0625. So 1/16 of an inch beyond where this neck pocket is going to be. Okay. So let's make sure that that actually is going far enough. So if we look at this view straight on, we should be able to see there. You can see it where the bit is going through the neck pocket, but not all the way down into our fixture. So if I simulate this, we kind of lose that in the simulation because the simulation is showing the stock. So if I turn the stock off, let's run that simulation again, but a little slower. And you kind of have to figure out what the neck pocket is here, but I think it's right here. Do one more. So you can see the bit going into the neck pocket and doing all 4 holes. That's why it came down apparently in the same hole, but it was just doing these 4 holes. One more and we can see it going through the hole and doing all 4 holes. So I'll go ahead and turn the stock back on. All right, so that's that toolpath. The next one is this contour operation to free up enough space for our roundover bit to be free to come down the side of the guitar body. So I'm going to double click. This is a 2D contour. So in geometry, what I picked was, let me unpick it. What I picked was this line right here, which conveniently goes all the way around the guitar. So that's my selected contour for the geometry. And I don't think I picked anything else. I mean, it goes from stock top to, okay, I went from stock top to 1/4 of an inch beyond stock top. I'm not sure that's necessary, but let's see what that does. Oh, okay. I'm confusing the matter here. I thought I was doing the roundover. So we're doing the profile around the outside. And yes, I specifically want that to go down a certain amount. I was figuring 1/4 inch would give us more than enough room to have that free roundover to go. So let's go ahead and simulate that. And you can see what's happening here. So this is 3/8 of an inch bit, because we're going to use a 3/8 inch ball nose. And you can see that it's taking 2 swipes horizontally. So I'll show you how that's set up. And also that it's leaving material on the sides of the guitar, because we want to finish the side of the guitar all in one operation, and that's going to be done after we flip it and after we glue the top laminate on. So I think that's done. Okay, so this is a 1/4 inch trough that's basically been cut here. So let's go into that toolpath and take a look and see how that was done. So the geometry again was this outer section of the guitar. The heights, again, we started from the stock top and went down from stock top a 1/4 inch downward. Passes, now we didn't cover this, so in roughing we're going to do 2 step overs, so 2 paths around it, and we're also going to do multiple depths. So being conservative here, with a 3/8 inch bit, I'm coming down 1/8 inch at a time. And that's all that I changed there. Oh, another thing is I turned on stock to leave, and radially along the walls, I'm leaving 20/1000ths of an inch. So I don't want to finish this right up to the final dimension. And I do turn smoothing on anytime there's a curved path. So that's turned on. And that's it. So you can see here with the toolpath, there's 2 rings around the outside, and then it looks like it drops down 3 times. If we look at it straight on from the side, we can see here are the 3 drops. Okay. So the final operation in this setup is going to be this round over operation. And the only thing tricky here is how to select this round over. So tool-wise, we're using 3/8 inch ball nose. Geometry, basically, all you have to do here is to say you've got a machining boundary and pick this line right here. I'm going to turn off this avoid touch faces and just see if that's actually needed. Let's see what happens to the round over here. Okay, so it's just generating. You can see the percentage of, how far it is finishing its generation. Now, you can see the problem, okay? So this is a scallop toolpath, which is a 3D toolpath right here. And 3D toolpaths try to figure out anything that needs to be finished. All we did was tell it, okay, here's the machining boundary. Anything within this machining boundary that needs to be finished, go ahead and finish it. We specifically don't want it to touch the middle of the guitar. So that's why I had this avoid touch surfaces on. And now I'm going to select this surface and say, don't touch that. Actually, I'm getting the whole body, so I don't want that. I want just this face right here. Okay. And so that face should not be touched by this toolpath. And you can see, first off, it's generating a whole lot faster, and you can see it's conforming just to the edges here. And you see that it is coming down quite a bit. So that's why we wanted to cut that trough to give enough area for this bit to get down into. Another thing, when you're operating with a ball nose on a toolpath like this, you almost always want this contact boundary point on, and I'll show you the little pop-up here. So basically this allows the bit to go outside your containment area to finish its round over. The bit itself has to go beyond this red line. Okay, so those are the 2 things in geometry. We had to do a machining boundary here, and we had to tell it to avoid cutting on this surface. Heights, we really don't have to worry about. We're going from stock top to model bottom, but the toolpath is restricting how deep it's going. Passes, step over here, I've got 20/1000ths. That might be a little overkill, but I wanted a smooth round over. If you want a super smooth round over, make that a smaller number. And again, I turn smoothing on for anything that has a curved toolpath. Okay. Okay, so I'm going to collapse up this setup And then I'm going to activate the next setup, which is the top of this base. Again, before the laminate comes on the top. I do have an extra sketch in here, so I'm going to go into the model section and click on the sketch to see where it is, so it's inside the body, and turn all the body sketches off. Okay. So the purpose of doing these channels here is this is the only time to cut these. There's going to be a laminate over the top, and we won't be able to get at these wire chases. You could manually drill them yourself, but you know, why not? If you're going to do this lamination, cut these wire chases while you can. So let's open up this body base top, and we've got two toolpaths. So I'm going to go ahead and simulate the whole thing. Oh, let me show you one thing before I do that. So here was the body base bottom. Okay, and you might notice that the part automatically flipped itself over when I did the next setup. Well, the way to get that to happen is, again, to go into these named views, and I have a CNC top. If I go there, you can see that's what we're in now, and a CNC bottom view. So I saved a couple of different views here in named views. I did the same for the neck when we were doing that cam. So when you get the view that you want and save your named view, then you simply assign that named view to your setup, which it is right here. So that way when we toggle between these setups, we get the flip happening, which is very convenient to realize what you're actually doing. Okay, so now we're cutting the top. So let's go ahead and simulate all of the toolpaths at once. So here is cutting the control cavity. Now you might ask, well, why are you cutting that? Why not do the lamination of the top first and then cut the whole thing at once? That's what I intended to do, but I had some problems with these wire chase toolpaths and getting rapid collisions with stock, and the only way that I was able to get rid of that is to do this this excavation first, and then when these three cavities are cut, it's then going to cut the wire chases and be successful in cutting the wire chases. But I'll show you, once the top is laminated on, I don't go all the way down to this body base when cutting those three cavities. So here's the, okay, now it's finished and it's doing the next tool path. Doing a little bit of weirdity here. This is multiple passes on the cavities. So this control cavity is deeper than the two pickup pockets. So it's taking a second pass at this. And you can see that this is an adaptive clearing, cutting with the side of the bit. And when that's done, we're going to try to get rid of all of that little extra linking movements that you see there. Well, there's one trick we can try to get rid of those with. Okay, and you're seeing it's surfacing this all the way to the bottom. Even with an adaptive clearing, because it's a control cavity. You don't really care that it's absolutely smooth on the bottom. Okay, now it's into the second tool path, which are the two wire chases, which is all we really wanted to cut in this setup. But without the cavities being hogged out, I was failing to do so. So let's look at our two tool paths in detail. The cavities here, I'll open this up. And so we've got a 1/4 inch flat bit. Probably could go with a bigger bit here. So let's go ahead and do that. I'm going to select a 3/8 inch cutter. So these are my tools here in my cloud folder. And I'm going to sort this based on diameter. So here are my 3/8 inch. And I'm going to get a carving up. Either one of these would be fine. Okay. Now for geometry, all I did was select these 3 chains, basically the bottom of this pocket, the bottom of this pocket, and the bottom of this pocket. The heights should be defined automatically going to our selection. So basically it's just going to model bottom. It's not really, but that setting will work. Passes, we've got a 3/8 inch bit, so we probably want multiple passes here. Let's see. Oh, this is it. Well, where is that set on an adaptive? Struggling to see where that is. Oh, okay. Maximum roughing step down of 3/4 of an inch. That's pretty far. So let's go ahead and reset that to, let's say 3/16 because we're using a 3/8 inch bit. And do an OK. All right. So let's go ahead and simulate that once that's done. Okay, still generating. Okay, so now it's done generating. Click on cavities, click on simulate. We've got our bigger bit here, so it'll speed things up. And we didn't have any stock to leave on the edges. I mean, if you're concerned about that, you could do a finishing pass, doing a profile around the outside. So this is going to do our multiple passes here, so I'm going to speed this up a little bit. Now, I guess with an adaptive clearing, we can get a little bit more aggressive. So let's go in and set that step down to the diameter of the bit. So I'm going to stop this simulation, close this, double click, and let's see, go into our passes and our maximum roughing step down. We can use a formula here and actually say tool. I'll just type in tool and you can see all the stuff that all of the variables that are set here. So tool diameter is what we want. So that'll be 0.375 with this tool. So it's regenerating the tool path. Once that's done, we'll resimulate this. Not going real fast here. Okay, so it's done. So okay, so we're coming down a 3/8 inch at a time, which looks like that's the full depth of that pickup, of 2 of the pickups. And then we need a second and maybe even a third. Yep, a third pass at this control cavity. Okay, so again, the only reason I cut these ahead of time before that laminate comes on the top is that I was struggling to get these electronics wire chases to cut properly. So here is the wire chase. I'll go ahead and simulate that. And this is with a smaller bit. So this is with, I think, a 1/4 inch bit, but we'll check that. Here's the simulation. Quickly cuts those cavities. And let's open this up and take a look. So I do have a 1/4 inch flat end mill, and you can see the geometry that's selected here. So we went to stock contours and simply selected right here and got those 2 wire chases. Now, one thing I noticed is I've got tool on center of boundary. Let's keep this with inside and see if there's any change here. I don't think there's going to be, but with Fusion Cam, you never know. I mean, a good approach is change one thing at a time and see what it does and go from there. So it's regenerating the toolpath, and it's done. So let's simulate it. And that did a good job. Okay. So that is all we need to do on this base. And then next we'll explore this final set of toolpaths, our final setup. Okay, so if I activate this final setup, which is the body cap top, if I click on that, you'll see that the cap came on, and you'll also see that our stock got thicker to include both the base and the cap. So the way that we do that is basically in this setup, when you pick the model, in this case we're picking two bodies. If I click on this and we go into the model itself here, you'll be able to see that I clicked on body bottom, and I also clicked on this top bodies, this top piece within the top component. At one time in this model, I had both top and bottom as two bodies inside this folder, and I had to make the top its own component, which I made inside the body component, because otherwise I couldn't get it to show up in this case and hide in this case. If it was just two individual bodies, even though I was selecting them properly, the fact that they weren't, from an individual component screwed things up. So I'm not sure if that's a Fusion bug, but it's certainly a workaround. So let me collapse the model, and so we do have an error here, toolpath out of date. So I'm going to regenerate this one. So I just right-clicked on it and pressed pick generate out of the menu. So it looks happy. All right, now that that's done calculating, let's run all of these toolpaths at once. So again, the way to do that is to select the top level setup and then do a simulate, and they're all going to run. So now you can see we're essentially recutting those pockets, the control cavity and the two pickup pockets. But you see that we didn't go down. We did go down a little bit beyond the base, but not all the way into the base. I'm sorry, a little bit into the base, but not all the way to the bottom of the pockets. So this is a perimeter cut. And this is actually going to go all the way through down to the perimeter cut from the other side, and should probably go beyond. So we'll have to check that. And this is going to have a nice big meaty tab right here on the base, and another one right where the neck pocket is. Okay. And I think now it's actually doing the round over around the edges, which is by far the longest toolpath here. Okay, so let's close that and look at things one by one. So first up, we've got our cavities, and that's going to be a 3D adaptive. I'm using a 3/8 inch tool. If we go to geometry, you can see I've picked 3 chains, and I kind of pick these differently, so let me show you that. If I pick right here, actually that's fine. That's just that cavity. If I pick right here on this, that's also fine. I guess when I was doing it, I was probably down here, which was giving me the wire chase as well. So what I want is just the pickups. Let's try this one right there at the same spot. Now this is going to be problematic because that went all the way around the neck and everything. So instead, I'm going to click on that chain with my shift key held down to cancel it, and then come down here to the very bottom and pick there. Okay, so the heights are going to be determined by by the cavities, but what we're going to do in this case is we're going to limit the depth of this cut so that it goes a little bit beyond this laminated piece, because the rest of it's already cut. So to do that, we start at the stock top, which is the top of this laminate, And then we're going to go down to a selection. So let me kill that and show you what I selected. I actually selected any of these edges right here. We want to go down to that plus, actually minus, in a downward direction, another 20 thou to make sure we're going past the top cap. So let's go ahead and take a look at the toolpath. I'll simulate just those cavities. Speed this up a little bit. So there's the first pass. Doing all three pickups. And then the second pass on the controls cavity and the pickups. So these are all going down to, a little bit below that line that was selected, which was the bottom of the cap. So that's our first tool path on the top cap. Let's go ahead and simulate this neck pocket roughing. So this is a adaptive tool path. It's going to bore down and then use the side of the bit to clear this out. I'm using a 3/8 inch bit, so it's moving along pretty quickly, and it's leaving material on both the sides and the walls. So let's go ahead and look at that in detail. So 3D adaptive, 3/8 of an inch bit. Our geometry was pretty easy to select here. Just this chain right here is all we really needed to do. Heights going from stock top to model bottom, or we can actually go to a selection, or let's do that. We'll go to a selection right here. That's our bottom. And in passes, I've got stock to leave of 20 thou radial around the sides. And let's do the same thing axial, because we want to come in with a final pass to clear everything out. So just making sure I haven't screwed anything up here. Let's simulate that. There it is, helixing down, using the side to clear out, doing a second pass. So I probably set a depth of about 1/8 of an inch, but we can go in and check that. Let's see what our pass depth is here. So I'm going to edit the toolpath and go into passes and optimal load, minimum cutting radius. Oh, so here's our maximum roughing step down, which let's set that to 375, which is the same as the diameter of our tool. Okay, so let's go to the next tool path. So that's roughed out, but we left material on the sides and on the floor. So now we're going to do a finishing tool path, and this is actually a pocket, 2D pocket. So this is using a 1/4 inch bit so that it can get in these corners, and basically we selected the same area and made sure that this arrow is inside the pocket that's selected. The height goes from our stock top down to our selected contour, which is, this ring. And let's see, passes, we do not want multiple depths on because we just have a little bit of material to remove, so we can do this in a single pass. So we want to make sure that that actually happens. Let's see, it's actually spiraling down, air cutting, and then getting to the floor here and exposing the actual neck pocket. Now, my experience, at least with my CNC, if my neck is a certain size and I make the pocket the exact same size, it's not going to fit. It's going to be too tight. So what you could do is make this finishing into its own setup so that it can be run multiple times. So let's go ahead and do that. So I'm going to go to setups, right click, make a new setup, and then I'm going to say, okay, I'm going to take the stock from the preceding setup, and let's see, we want to model. We're going to go into the model in the browser, and we're going to select both this top and the bottom, those two bodies. Okay, now when I made this new setup, you'll see that the machine, this doesn't look anything like my machine, but I guess that's the default machine. I'm just going to hide that by clicking on the name of my machine. Okay, so we want this as a separate setup, and we want to drag this neck pocket finishing into this setup. The reason for that is we can run it multiple times with differing amounts of stock to leave, even a negative stock to leave. So let's go back in there. Our pocket is still selected. Our tool is correct. Our heights are correct, going from stock top to selected contour. And this is what would change. We would go into stock to leave, and let's say the neck is still not fitting, it's too tight. We can actually do a negative on the radial, on the walls. I think on the bottom I would leave that at 0, but we can tweak around with this. I would probably say what you want to add, at least again on my machine, what I would want to add is 5 thousandths will be enough of a overcut to do it. But keep in mind we're cutting 2 walls, so that doubles the extra amount that we're cutting off of here. So I would set this to 0025 is what we're cutting, overcutting. So let's call this, I'm just slow double clicking in here to rename this, and this is going to be neck pocket fitting. So since this is in its own setup, we can just continue to run that setup as many times as we need. But before we do that, just go in here and set our stock to leave to eat a little bit more. So it's overcutting by 0.0025. So 2.5 thousandths at a time. So let's go ahead and simulate that. Now what we're not seeing in this cut is the fact that this is already cut away in another setup. But we should be able to see that it's cutting to all green, and it probably would go red here if we had a little bit more area that we're biting into. Or maybe, I'm going to try to change the accuracy here. Not sure if that's going to work or not. So I'll do one more here. This does slow down the simulation quite a bit. I don't seem to be able to move the accuracy beyond that. Let's see if we resimulate. If we get red walls, which it really should be. It's overcutting, but it's overcutting by such a small amount, it's not showing up as red. Okay. So back in this setup, we have 2 more things to do. We need to cut the body contour, and then we need to do the round over. So let's look at the body contour here. So you can see the toolpaths, and you can see that this is actually a tab here and here. But let me go ahead and run the simulation. So now it's going around the perimeter of the guitar. It's leaving, it's actually cutting 2 trough around there. And then it's stepping down probably half the width of this tool is probably what I set there. And then what it's going to do is it's going to do a final pass using the full depth of the cutter. So the reason I did 2 pass horizontally is so that there's no stress on this bit when it's doing the final cut. You'll see that when it does these 2 passes, it starts with the outward one. See right there, it's cutting the outward path. Then it comes in. So there's no stress on the bit when it's cutting the inward surface. So okay, so there's the final cut where it's revealing green. It's cutting right down to it. So one of the things I want to make sure is that we've actually cut down far enough. We don't have to cut all the way through it, but we do want to cut down to the round over on the other side. So I'm not sure that is deep enough. So let's go back into this toolpath and edit that, the contour, and also take a look at it so in detail. So here's our 3/8 inch flat bit. When we go to geometry, very conveniently what I picked was this chain right here, which goes all the way around. If I had picked this chain, I have the neck pocket to deal with, but this one on a Telecaster anyway is very convenient. That is the outer perimeter of the guitar, just because it has straight walls everywhere up until the roundover. So that's all that has to be done there. The tabs, I turned the tab section on, and what I did was I went to, you can either have tabs by distance, which Fusion's figuring out the distance between tabs and just putting them in there, or points where you're selecting where it's going to go. So I can click anywhere on this line here to be right in the bottom middle of the guitar. So I'm going to go there, and I'm also going to go here, figuring that these areas are very easy to get to when we're finishing off the tabs, and B, at least this one here is not, you probably won't see it very much because the neck's going to be right above it. So, and they're opposed to each other. So I made these tabs really meaty, 3/4 of an inch wide and 1/2 of an inch tall. So that's a pretty hefty tab. Maybe we'll even go to 1 inch. So there's a 1 inch tab there, 1 inch there. And you can see that tab is going to end up on the bottom of the toolpath. So this is a good indication that we have not gone deep enough with this perimeter, because the tab starts at the bottom of the toolpath. So we actually want to go down to this selected contour and maybe even a little bit more. So when we go to our heights, we want to make some changes here. So we're starting at stock top, which is the top of our cap, and then we want to not use model bottom, but actually let's see if we can do a selection. So I'm going to do a selection, and I'm going to pick this line right here as our depth. Okay, and now we want to exceed that. We want to go a negative amount past that. Doesn't have to be 1/8 of an inch, but I'm going to do, let's try 20 thou, just to make sure that we exceed that roundover, which the roundover is already cut. So what this is going to allow us to do is this plumb, this vertical wall is all going to be cut in the very last pass of this contour. So let's go ahead and simulate. I'll speed it up a little bit and slow it down when it's getting close. I'm going to just kind of rewind. I'm just kind of scrubbing backwards. Okay, so we're getting back to where we have blue on the walls. I'm going to slow it down here and hit play. So now we're, oops, I didn't bring it back far enough, sorry. Okay. So now we have material all the way around the perimeter of the guitar, and it's getting very close to doing its final pass. This is its final pass. It's at full depth, and it's doing that wall all at once. So we can see the tab in there. Now the reason that it looks like it hasn't cut all the way through the guitar is it doesn't know that the other setup is actually run before it. So we're going to run these two setups together once we're done here. So that's the final contour, and then all we have to do is a round over, which is pretty much the same as what we did on the opposite side. So a tool, we're using a 3/8 inch ball nose. The geometry is a selection of this round over area. And the heights, the scallop toolpath is going to figure out the heights automatically. So I just went from stock top to model bottom. Passes, here's the step over of 20 thou, which is going to get a nice finished round over. And that's pretty much all I did there. So let's see. That looks fine. That's doing the round over all the way to the edge here. So we can simulate again. I'll speed it up because this is going to take multiple passes. So you see it's not going into the neck pocket area. But we want to make sure that it's clearing out all this blue here. And that looks good. That's all gone. We've got a nice round over. Okay. So that's the final tool path except for the neck pocket fitting. Okay, so now we want to take a look at the guitar with these two tool paths going at once. So I'm selecting these two. I'm going to open it up so we can see which one we're in. And what I like to do in this final kind of walkthrough is when I simulate, now this error comes up, well, it's not really an error, warning, saying that you've got two different work coordinate systems, which is fine because we're flipping the part over. Okay, so the base top, what we should do here is do that. Oh, you know what? We actually want to do all three of these. So we're going to simulate all three of these guys at once. We'll start by activating the base bottom. Then I'm going to do a click and a shift click here. And let me open this up. So now we're going to simulate all three of those. We're going to simulate the bottom of the base cutting, the top of the base cutting, and then after we laminate the top cap on there, we're going to simulate that cutting. Okay. Again, it's complaining about the different work coordinate systems. Okay, so now I'm going to not let it run. I'm just going to step through operations. So that was the ferrule holes. It's about to do the neck mounting holes. So we'll go to the next operation. The holes are cut. Now we're going to do the shallow contour around the bottom just to open up enough space to do our round over. Then we're going to do the round over on the bottom. So that is now done, and it's actually waiting on the other side to do the cavities. So let's step through that. Our cavities are cut. Then our wire chases are cut. And now it's in this top cap. So this is going to be a little difficult because we've got another piece of stock here that we're not seeing. So it's going to look like it's cutting nothing. But when we get done, I want to see that, you know, this perimeter cut went all the way through the pieces. So that was the cavities of the cap, which we're not seeing. So kind of have to imagine that happening. And this is the neck roughing has happened. Again, this was much deeper because we're not seeing the cap. And now there's a round over that we're not going to see anything. Oh, this was the contour. This is what I really wanted to see. So the contour has gone all the way around. There's the tab. And the contour has gone down to our roundover from the other side. And here's our other tab on the other side. And then this is the final roundover, which again we're not seeing because we started with this base top as the activated setup, and that didn't have the cap in it. So that's it. That's all that's involved. The Telecaster is a great simple guitar. It doesn't have any comfort cuts in it or whatever. So the cam is about as straightforward as you're going to get on a guitar. So it's a good model to start with. I wish I had started with it. I got into a PRS initially, which was much more difficult. But I will be doing a series on the PRS next. So anyway, I've enjoyed doing this. I hope you've gotten a lot out of it, and I hope you watch the next series on the PRS.